Let's go to Elitech Tools. So it'll be that one. And I need you to press record. And actually, I'm going to have you, the instructor, download this. I think it'll be easier for you guys to have it and just cycle the students through. When you press connect the Wi-Fi signal, you should see the device and you're going to click on the device. And then from this interface, you're going to click on graph. And from graph, we're going to watch the student's pressure application. So I want to measure their softest flush, their normal flush, and the hardest flush. When we do this, we need to open the three-way valve all the way. All three parts need to be open. One more thing I need you to do is to apply the clamp to about here. This squeezes and closes the diameter of the tubing to match at about a 20 or 22 gauge catheter. So after you've applied the rolling clamp right about there, we're gonna flush as hard as we can and measure that. Okay, so my maximum was about 80. Now I'm going to measure my regular pressure. Look at that. Even my normal flush is hitting about 30 psi, which is already at tire pressure. And this is my most gentle flush. This is probably, after I learned about this, I started flushing this gentle. So this exercise will teach and quantify and teach the student about how much their thumb pressure actually is being applied, how much pressure they're actually applying, so that when they go back into the hospital and go back to their practice, they can change how hard they're actually flushing. This next exercise is to demonstrate, and we're going to open this wide open, is to demonstrate the Poissier's law. The smaller the diameter, the higher the pressure you can exert. The larger the diameter, the lower the amount of pressure you can exert. What does this mean? When it comes to effort, how hard I can push it. I'm going to be able to apply more pressure with this than with this. Let's do it with an even smaller syringe. Let's do it with the 3cc syringe, and I'll show you the bigger differences between the two. So we're going to demonstrate how much more pressure a thinner diameter will be able to apply versus a larger diameter. I'm going to force this and push it as hard as I can. So let's zero this out. Hold that button in the middle, and then it'll zero out. So this is as hard as I'm going to flush. Didn't even read it because it's too quick. All right, let's do that. 162. Let's try that again. Say 162. We're going to zero this out. And now I'm going to flush this as hard as I can with the 50 milliliter. Look at the difference in the amount of pressure that I can apply. I'm pushing this as hard as I can. I'm going to flush as hard as I can with this 10 milliliter syringe, or 50 milliliter syringe. So that's about the most I can exert, is about 20, 25 was the highest I got. Now let's see what it looks like with a skinnier 3cc syringe. Significantly more. And the reason why there's such a difference is because this is only reading so many seconds of time. So it needs to catch it right at the highest peak, but unfortunately, I gotta time it perfectly. Okay. So the most we got was about 100 something. That is a significant difference from 20. And what I want them to realize is when you're flushing with different diameter syringes, to be thinking about and be mindful of how much pressure they're actually applying and pushing into the body. So, to be mindful of how much pressure they actually need to be exerting and how much effort it takes. Of course, the pressure output will be different depending on how hard I try or how little I try. So, there is a variable of effort and the clinician's ability that will determine the actual PSI or the pressure of what we're doing. However, we still don't have thorough research on the actual quantification of what we do in the hospital or to our patients. But this concept of fluid dynamics and how it applies to our practice is going to be important in increasing the dwell time of these catheters. What is important to nurses? It's the catheter staying and working for as long as possible. So these theories and this application will hopefully allow the clinicians to think a little more deeply about what they're doing down to a physics level, a granular physics level, so that they can adjust their practice to improve patient outcome.